Hello, I welcome you all. The problem reads that the conveyor belt delivers each 12 kg crate to the ramp at A such that the crate speed is VA equal to 2.5 meters per second directed down along the ramp. If the coefficient of kinetic friction between each crate and the ramp is mu k equal to 0.3, determine the speed at which the crate slides off the ramp at B. Assume that no tipping occurs. Take theta equal to 30 degrees. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. Of course, we have two problems. We are only going to solve one in this particular case, and we'll solve the next one in the next video. So we have case 1, which is 13-20. And here we have a conveyor belt delivering crates of mass 12 kg each. We've been asked to determine the velocity at B. Alright, so this particular crate is going to cover a displacement distance of 3 meters, and we are assuming there is no tipping, so therefore it means we are assuming this velocity here. You've seen this velocity becomes our initial velocity the moment the crate is on this particular lamp. It will have this initial velocity, so this has to be considered. Okay, so this is not starting from rest, it has initial velocity. Okay, great. Let's draw what is happening. So let's draw. So let's say we have this crate like so. This is the crate, something like this. Great. And let's imagine that is the lamp, something like that. Okay, and then this point here is B, this point here is A. Okay, and then we have this distance here. Let's imagine we have this distance here given. This distance here we are assuming, not assuming, is given. This is given as 3 meters, right? This is 3 meters. Okay, so this is going to have some mass acting to the center of gravity. So let's say that is our mass W, and then this is going to have some components. It will have one component in this direction like so. Okay, then it will have another component in this direction like so. Okay, all right, this angle here we've been told that it is 30. So let me just transfer this angle there. So if we know this like this, we know this, and then what else do we have? Let's say we have this, and then we have this like so. So this angle here is 30, right? Okay, this becomes 60, right? Then what does this one becomes? It becomes 30. Is that fine? Great. So let's write down. So this angle here is 30. Okay. That is 30. Okay. So that one is 30. So now this one just becomes W cos 30, and then this one is W sine 30. All right. So what components do we have here? So this is moving in this direction like this. Is great as it tips off. So we'll have some kinetic friction in this direction, and then we'll have some normal force there like that. Okay, so this is our N, this one is our FK. Then here our V naught is going to be equal to 2.5 meters per second. This we have to take care of. Okay, have to remember this. So now let's write down the equations. So we can also write down the kinetic diagram here if you want to, like so, in that manner, like that. Okay, so we have movement in that direction like so. Okay, so let's write down the equations. So let's start with and then our reference coordinate is inclined. Is like this. Okay, so this is our y and this is our x. Okay, so let's say summation of forces in the y. We start in the y because we need that kinetic value. Summation of forces, this my like this, but we know to say this is going to be equal to 0. Therefore, we just have n minus w cos 30, okay, which is equal to 0, and then n is just going to be equal to w cos 30, which is just equal to mg cos 30, and our mg, we know the mass of the crate is just 12, then times 9.81, then cos 30. So we know the value of n. So with the value of n, we can find the other problem, which is summation of forces in the x equal to max. What do we have here? So here we have w sine 30 minus fk equal to max. Our w we know to say is just mg sine 30 minus mu k n equal to max. So this we know it is 12 by 9.81 sine 30 minus mu k, which is 0.3 times 12 times 9.81 cos 30, okay, equal to let me move this, that become a little bit long. I take it this side, equals to m, and our m is just 12, then times ax. Therefore our ax is just going to be equal to, so we have w there, 12, 9.8 sine 30 minus mu k f k, which is the kinetic friction, 0.3 by 12 by 9.81, then cos 30. All right, so let's work it out. 12 times 9.81 sine 30 minus 0.3 times 12 times 9.81 cos 30 divided by 12. So this gives us a 2.36 meters per second square. Let me check it again. 12 by 9.81 sine 30 minus 0.3 by 12 by 9.81 cos 13 divided by 12, 2.36. Okay, right, so with this information now we can find the velocity. Alright, so what are we going to use? We have distance and velocity. I'm going to use this A ds equal to V dv. You know where this is coming from? This comes from V equal to ds dt and A equal to dv dt. Making dt subject to the formula, then you can arrive at that. Okay, so with that, we know that we are going to integrate from this distance here at A. We are going to say that is our 0 to S, and then here we have our V naught to V. So our V naught is equal to 2.5. What else? Our S is equal to 3. Our acceleration is equal to 2.36. What else? That's about it, right? So this just becomes A. It becomes AS is equal to 2.5 to V dv, like so. Okay, and when we plug in the value there, let's come down here. Let's just make a bit of we come down here. All right, let's come down here. So this one here, our S is 3, so this just becomes 3a is just equal to, this one just becomes V squared divided by 2, integrating it from, evaluating from T to V. Okay, right, it just becomes equal to 3 times 2.36. Okay, so this one, evaluating it just becomes a this top minus the rest, so this just becomes a V squared divided by 2 minus 2.25 squared divided by 2 equal to 3 times 2.36. Our V, therefore, our VB will just be equal to, our VB is equal to, let's work it out. Mind you, there is a squared there. Let me put direction in advance, like so. Okay, our V therefore is going to be equal to 3.3 times 2.36 plus 2.5 squared divided by 2, then by 2, then square root of answer. So this we get a 4. We get a 4.52 meters per second. So this is the speed at which each crate slides off the ramp at B. Right, I guess we are done. Let's just outline the final solution, like so. Okay, so I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye. and I'll see you in my next screencast.